I'm Jan Broos. I'm a naval architect, but working as a senior sales manager in cadmatic. Yeah, cadmatic hull is a software to model the hull structure of a ship, or vessel, whatever you call it. It can also be used for offshore structures. It's not only for ships. In my presentation, you will experience the main functionality of the software and also the main advantages, which in my opinion are the user friendliness and the speed of modeling, and also the speed of getting production information from it. I don't speak too much about the software itself. I think that the demo is really meant for it, because working with it is explaining much more than talking about it. I will do the sales presentation for you a little bit different than I usually do, but only in the beginning. So the idea is to model this part of a ship, what tanker it is, and we do that from scratch. And scratch means that you first need to have a block available. How the start is. So I'm switching to system management, and opening the building block overview, and you see the list of blocks, and these are blocks from thousands. Those have been carried out before, and I take the last one and I make another one number higher, and I add, modify and confirm. And I need to activate the new block 1093. I have to decide which neighbor blocks should be visible or dashed or invisible, and I will make these ones invisible. All the blocks which have been used in previous presentations should not be visible anymore. Okay, that's it. Okay, and now we can start with the real work, and that real work will start in the application 3D Show. Okay, here we are, and I will define an area from frame 24 until frame 41. Minimum breadth 4 meters from center line, minimum height 8,000, and the maximum height 14,000 millimeters above baseline. And then to show the audience where we are working and a little bit how we are working, I'm activating the frames, butts and seams lines, and they are displayed on the screen, as you can see, hopefully. And you can rotate them a bit. So I see there are a few lines which should not be there, but okay, it is like it is. From now I will start the structure, to make the structure, and the first items will be decks, so that will be here, and the first deck is at a level of 9,600 above base with a thickness of 10 millimeters, and the second one is 12,800, and the number of decks are 2. A different material can be used, so you can choose from this table the type of material to be used, and if your type of material is not shown here, you can easily add it later on to this list. Okay, from now we'll get a top view, and then we need to define the borders of the deck, and the aft border will be frame 26, but not exactly, it will be 650 millimeters in front of 26. Then we go along the hull line until the front border, and that one will be on frame 39, but again not exactly, 150 millimeters in front of it. And from center line it all starts at 7 meters. And then we can confirm this and here we see the two decks. Next one will be two cross bulkheads. The first one at frame 27 and the thickness will be 8 millimeters, and the second one at frame 39. Again, two items, so two bulkheads. And here we see the cross view, and I want to connect this cross bulkhead to the deck, the lower deck I just created, and I do that by just clicking the deck, clicking the hull line, clicking the upper deck, and entering once again the 7 meters from center line. And by doing this, a so-called topological connection is created. So meaning when the deck will be lifted in future or put down, then the red bulkheads will automatically follow. Okay, then the next item will be a longitudinal bulkhead. So we find it here. The position from center line will be 8 meters, but I have to enter it in millimeters, so 8,000, and the thickness will be 7 millimeters. By the way, values on port side are negative values and starboard values are positive values. So 8 meters, thickness of 7, and longitudinal view is made, and this one is very easy to make, just 4 clicks, selecting the surrounding structure and one OK button, and the bulkhead is over there. Okay, I like to make one more sorry, longitudinal bulkhead, and by doing this I can select the panel again, but I can also use enter, and then my previous panel is loaded, reloaded. So, and I immediately can entering my values, position from center line together with the thickness, and here we see the situation, and I select my borders. By the way, there's only one requirement, and that is that it has to happen counterclockwise. Third boundary and the fourth boundary I like to indicate by means of a length, and the length is frame 33 but 25 millimeters behind it. And as you can see in green, the bulkhead has been created. I can also hide the hull lines, then we have a little bit better view inside the block. And now it's time to create another cross bulkhead to make the tank complete. And that cross bulkhead I like to locate at frame 33, also with a thickness of 12 millimeters. Yes, and I think you already can do it by yourself. It's quite easy, selecting the 4 boundaries and pressing OK, and the bulkhead is there. Okay, that's enough for plates at the moment. Now I like to continue to make some shell frames. That's this button. We have all kinds of shell frames. They can be horizontal, they can be transversal, they can be longitudinal in the bottom, for instance, but they also can be perpendicular to the shell, so there are no limitations. At first I like to start here with some transverse ones. Doing this will open this panel where you have to choose your profile type, and I will take a bulb profile of 200 times 9 millimeters, and the first one I like to locate at frame 28 and the last one at 32, and then automatically all the frames in between will also be filled with a shell frame. Okay, cross view is shown. I want to start from the lower deck with a small gap of 40 millimeters, and then an important part is coming. You see here all the end types, all different type of end types, kind of end types, whatever you call them. But I prefer to use the outer button. The outer button takes care of that the right end type is chosen all the time based on the customer's situation. So I take the auto here, and from the upper deck I want to have a space 180 millimeters and also the auto button. It needs some setup work to get the auto button working, but once it has been done, it's real big benefits. And you see there are 5 shell frames. Here in the tank area I like to create some horizontal shell frames. They have a fixed height. Again bulbs, but this time 160 times 9. And the first one is located at a value of 10,240 millimeters, and the last one 12,160, and the spacing is 640 millimeters. Okay, here it goes. We see the top view, and I like to start from the aft bulkhead, automatic end type of course, until the forward one, and the same, and then in a split second you see the 5 or 4 shell frames. So this is how you can work in a 3D show to set up the skeleton of a block. But if you like to go into more details, you cannot do it in 3D show. For instance, we have no options to create brackets, so we have to do it in 3D contact, and I'm switching over there. No need to save the changes, because as explained earlier, all the paths have been saved into the database. The save command only could mean the saving of the picture, not the data. So now we are in 3D contact. We have much more options now. We have brackets, flanges, etc., etc. We will not work in 3D environment anymore, but we will work in 2D views. And we can open the views if they exist, but as you can see here, it's completely empty because we started from scratch. There are no any views. So they have to be created. You can do it in a manual way, frame views, side views, top views, but we have a more advanced option, and that is this one, create views automatically. When starting this, or after starting this, views will be created, 2 deck views, 2 longitudinal views, and a number of cross views based on the structure I just created in 3D show. Working only in 2D views would not be sufficient, and therefore we have this hull viewer. I try to open it here. Yes, so you see here the hull viewer. It's not only for viewing. You can also, for instance, hide parts like this, but it's also quite easy to get information from a part. You just press the I button on the keyboard and you get the main particulars of this plate and of this one, whatever. Another nice feature are these filters. So if I click this thickness filter, you see different colors. And that means, that represents different thicknesses. And that's easy for, let's say, for managers to check if the right thicknesses have been used, if the block has been finished. There are also filters for the material, so now everything is green, but if I would have used a different material than the standard material, it would have been displayed by other color. And also, for instance, nesting status can be shown, but that's not active at the moment. But that's enough for now. In the meantime, views have been created, and now you see there's a big bunch of views. And I will open this one. That's the view of the top view of the upper deck. And you see here the tank created in 3D show, also the longitudinal bulkheads. And in white lines you see the neighbor blocks around my block. They are displayed in white dashed lines. The first thing what I always do is to add a text, so that you easily can see that you're working in deck 12,800 above base, and you can move the text to the right position, and that's it. Next will be longitudinals underneath the deck. Maybe just a small reminder that those are these ones. So I can search for the button, for the right button, but what's also nice, I think, explaining a bit about our GUI, if you click for instance on a bulkhead, only plate options are shown in the toolbar. If I click on a profile, I only see profile options. The first part is always the creating part, and right from it are the modifying parts. I want to create new ones, horizontal ones, bulbs again, but now 140 times 7 millimeters. I could enter a value from centerline here, but unfortunately I forgot about it, and to make it more easy I can press the key button number 2, yes, and then there is a kind of a transversal framing system shown on the left side of the window, and I will use these. That has quite an advantage, especially in the basic design, because when there's a change in frame spacing, then you only need to change to edit the file behind this, and then all the structure will be relocated according to the new position of the grid. So I'm using the grid. I'm starting at L9 and I'm ending at L17. They are displayed here, and I want to start at the aft bulkhead, of course with automatic end type, and end in the front bulkhead. And there they are. The same inside the tank, so enter to repeat the last command, and that goes from L19 until L20, and from here until there. If we now have a look at the hull viewer, you'll see the stiffness here. This area, it's better to have vertical profiles, so I'm using this button, and they will go from 28 until 32, and from hull line until longitudinal. And because I have used this auto button, there is automatically what in English is called, I think, a rat hole. So you see there a radius of 35 or 50 millimeters automatically there. What's also nice, that everything is connected to each other. So when I move, let's say this longitudinal, and I move it in width, maybe 150 millimeters into the direction of port side, all those transverse ones keep connected. Yeah. Okay, this was preliminarily the top view of the deck. I now prefer to continue with the cross view. I click on one of the beams and it's opening the frame 30. This was the automatically generated view, but it's not up to date anymore. That's why I have to press this button, and now we see the actual situation. And I always recommend to put text, and I activated this panel by using Shift and right mouse button. Then it shows the last 7 used commands, so I easily can capture this and put it over there. Okay, now zoom into this this end type, what I already showed in the hull viewer. So there is a little bit more with it, because when I rotate, when I rotate this one, automatically the end types have been changed, but also the profile is automatically 7 mm shorter because the thickness of the profile. So that can be achieved by means of this auto button. And another one small example, if I extend this one for whatever 20 millimeters, the profile will be automatically sniped. So you can add your yard specific standards into this auto button, and it means that in every situation you will automatically have the same end type irrespective of the users of the software. So you have always the same. That's quite important in my opinion. Good. That's about these details. Now I like to continue with some bigger stuff, and let's have a small view at a PowerPoint. I like to create this web frame. Of course we already have some stuff over here, so that needs to be removed. These two and also one over here, and they are gone. Now I like to make the plate or the web. First the plate, and later on I will add a faceplate to it. The plate will be 10 millimeters. You can start wherever you want the defining. So I'm starting on the lower deck. I want to have a cutout of 75 millimeters. Then I continue along the hull line, the upper deck, connect to the port side girder, and now I once again select the deck to get an offset from it, 500 millimeters, and I like to have a radius of 300 in the corner somewhere here, and to end with an offset from the hull line, also 500 millimeters. If you're not quite sure of yourself, then you can use this preview button, and it gives you a preview of the plate. And it's quite easy to make changes. So if this radius should be 400, we change it into 400, another preview, and it will actualize the situation. And after pressing OK, it will save into the database. But still now you can make every change you need, even if it has been saved into the database. I will give an example later on. So what I like to do now is to make cutouts around this deck profiles, and we can find it here. Construction cutouts, cutouts lux. Make a box around the profiles, press OK, and the panel is opened with all the available cutouts, and I take this one, this is the most used one, and press OK, and they will show up, and there they are. Okay, sometimes there is a need for changes, so that I also will show. So these two, they need to have a so-called lock. You see it here, and I press OK, and they have been added. And also these small things, of course, are shown in the viewer, as you can see here. And again, when you use the I button of the keyboard, it also shows up these small items, the weight, length, breadth, width, thickness, and also the center of gravity, of course. Some other modifications are possible. For instance, if somebody asks you to change the profile type, so that can be done by this button. Maybe I do it for two bulbs. I'm gonna change into angle bars, 150, flange width of 90, and there they are. And now you see that the cutout has been changed accordingly. Another thing to show is the direction of these two. I'm now swapping, and you see the cutouts are following. automatically, and in case I would remove the profile, also automatically the cutout is removed. Alright, now it's time for the last action here for the web, and that is to add a faceplate. And that is one. We have different kind of faceplates, but I will now start with the banded one. It asks me to indicate where I want to have the faceplate. That's over here. I need to define this about decide about the size, 150 times 10, and the starting point, which will be here. Then end type. I haven't defined here set up the auto buttons. Could be done, but not been done yet. So I put the A over here, and the ending point is here. 25 opening, and that will be a snipe. And then OK button to confirm everything. And you see here that automatically there's a symbol added, which I think is good. And of course in the viewer we also see the snipe here. It's not only about modeling. Oh yeah, and if I do the update, we also see automatically the thickness. It's not only about modeling. I will also the shipyard also needs to have more information about sizes, etc. on the drawing. So I will add some more 2D stuff, and one of those will be the diameters or the radius. Here 400 millimeters, and this one is 75. Well, yes, it is. And also the height of the girder I like to add. It's a vertical one. The sensitive button, but now it works, and it goes from here to there. 500 millimeters, and also a label for the faceplate. And you can have it in both directions, or even if you use one of these buttons, it can be with an angle of 45 degrees, whatever. So that one. And you see here a so-called part number, which is now 0, because all the part numbering, all labeling, etc. will be done after the modeling has been finished. And you have also the possibility to add more. Not this one, so if something goes wrong you can use the K to delete it. I want to have horizontal one, so I want to have it from here, there, like this. Okay, for me it's okay now, so consider frame 30 as ready, but I like to have a copy of this web frame on 33. So I will now use the copying command, copy the web, including the faceplate, and shift it 3 frames forward to frame 33. And here it goes. Now I'm going to open frame 33. Here it is. And update. And now we have the actual situation. See here, and we add this text. There it is. Okay, and we see that the web has been adjusted to the shape on frame 33, so that's quite nice. But in this case it's a bit redundant, because there was already a bulkhead here on frame 30, so now we have actually a collision, 2 plates on top of each other, or even inside each other. So what I will show now, that how you can repair this, because this part is quite okay. I like to keep that, but I want to get rid of this part. So I want to modify this plate, the relations of this plate. At first the 400 millimeter radius is not needed anymore. Instead of that I will add a border over here and stop on the deck, and that should be enough to get the saturation I want, and actually it is. So now we have a clean saturation here, and we have a nice girder over here. But a new problem is there, because this situation will never be approved by the Classification Society. There need to be added a bracket here. So that's what I want to show now. Construction brackets in view, and here we have the panel of brackets which are available for this project, and in this case I think I need to use bracket D, asking me to indicate the first construction part and the second one, because the bracket should be located here, and I want to add my own 3 dimensions. 500, 50 radius, 10 millimeter thickness is okay, and there it is. And because this is a rather big bracket, automatically a flange has been added. And flange could also be a faceplate. If the yard is standard is faceplate instead of flange, then that also can be easily achieved. A little detail of the bracket, a little bit more detailed, and that's production detail. I like to so-called code this bracket, meaning that DXF file is created to be ready for nesting. It will happen in a right screen. Takes a while, but here we see it. We see the bracket including the flange, but what I like to emphasize a bit, that is there is a radius here, meaning that it prevents from cracking. So if the flange is bended, then there will be not a crack here in this corner. And what you see here, that is a so-called bending line. This situation only one, there could be even 3: start radius, mid radius and end radius. And you see some text here, meaning this side flange 75 millimeters. Okay, we return to the main screen, and I like to do one more copying action. Not only the girder, but this time also including the bracket. So 2 of these items, copy and shift another 3 frames forward, and there they are. And if I now have a look at the top view and update, we see 3 girders now underneath the deck. So we are back on the first view where we started, and I like to continue here a while. At first, to divide this big deck plate into smaller parts, because this never can be produced. So I will use the construction weld command. Horizontal seams, weld seams, that's about the same word. Both are used here in the panel. So I select the deck, and I'm entering the position of my first weld or seam, 9250 from center line. The plate size is 2500 millimeters, and I want to have 3 welds. And there they are. Some symbols can be added, and they also can be customized to the shipyard standards, of course, and you see them here. Beveling is sometimes needed. I also like to show that. Construction bevels here. So we have automatic beveling, which I also will explain a bit, but we have also the manual beveling, and if you want to have a single bevel, for instance here, for this weld, you will get an overview of the available bevel types, and to make it a bit more visible you can have a preview here, so you can V plus, V minus. I think this one is a little bit more used. It has a small so-called nose here, and it also could have an opening. You can see, so you can define an opening when applicable, and you can save it. I could save this. I can do, and only the position of the symbol is a bit bad, that's why I'm not often do it. But anyway, now the information for the bevel is sent to the cutting machine, or first to the nesting and after that to the cutting machine, and the plate is cut according to this bevel. Alright, that's about the welds and bevels. A little bit more about 2D. I already showed you some manual dimensions, but nowadays we also have auto dimension. I will not explain it in detail, I will just apply it, and then we will have a look at the details. So what has happened in these past seconds, all these dimensions have been added, and just detail, but for some people quite important, that these arrows are pointing into the right direction. So this one up because the profile direction is inwards, and this one is down because the profile is going outside, and that also is represented by these symbols, as you can see. What more, here the plate size is displayed, and every individual longitudinal has got a dimension. And to show about the easiness of changes, if something needs to be changed, you can also do it in top view. I did it already in the cross view. I changed a bulb into an angle bar, but you can also do it here. So I can, this one I can select, for instance, these two, change them in 180, whatever, and we see the actualized text as well. Okay, that's about this. Yeah, maybe something quite different in between. That's about the drawing, how to create a drawing, because that's one of the end products of the modeling. So we have this sheet button here, so I will touch this one and I will create a new sheet. You can select the right size. I think I want to have A2 if I'm right, yes. Scale 1:50, and title field is displayed. Now the cadmatic one, but hopefully in future the customer's one. And all kind of data can be entered here for the title field, whatever. But most important things are coming now. You need to decide which views you want to have on the drawing, and for me it's the top view at first, the first one, this one, 12800, and we put it here. And I also like to see some frame views, the frame 30, which could be here, and below frame 30 I want to have 33, like this. And that's it for the moment. I save this. Yeah. You can plot or print it straight away from here, but also still a lot of people, they like to have a DXF or DWG of it, or PDF, and that can be found here, so you can use this button. Yeah. It's also important to know that modifications are not carried out in general. There are some limited possibilities, but in general it's not carried out here on the sheet drawing, but you will open one of the views, like this one. And now I will use a very bad example maybe, but I just will draw a line. Just an arbitrary line, and use again this longitudinal one. What I didn't mention right until now, I showed about the bevel, but we have automatic beveling. I think I mentioned, yes, and it's displayed here. So here we see a so-called V bevel 30 degrees, and this automatic beveling is also based on the yard standards, so that can be fully customized so that the bevels appear automatically, which also are used by the shipyard, and it avoids a lot of manual adding of bevels. So I think it should be used as much as possible. Now continue about, I'd like to continue about finalizing this longitudinal bulkhead. It needs to have some stiffeners, and first I like to display the grid, the height grid. In top view we spoke about the transfer grid, but there's also a height grid, because this bulkhead needs longitudinal stiffening. And that means, I think, 160 times 7 we can use here. Yeah, and it goes from H3 until H6, from there until there, and there they are. You see, they are dashed, and to be honest, that's not the idea to have. You can see them here, they are outside the tank, but it's much better. They also penetrate here the bracket, as you can see. So yeah, that's a mistake. Actually, I made a mistake. Now, human behavior, making mistakes, and that can be easily corrected. So you can use this direction button, select those, and change the so-called body direction, and very soon they have been changed to solid lines, and it also can be here, they are now inside the tank. Alright, so that's okay now, and now I like to open the top view of this lower one and update it, and we see here the stiffener I just created, and those were one of the very first ones created in 3D Show. So a little bit more detailing. At first these stiffeners are rather small, only 140, and that they cannot withstand the pressure of the tank, so they need to be supported halfway, and by means of a bulkhead. So I will copy this bulkhead, again 3 frames forward, to have a bulkhead over here, and you see it's automatically adjusted to the new shape, or to the shape at frame 36. A stiffener here, 167 is okay. From here, automatic end shape until here. And that is okay. Brackets are needed. A little bit more about brackets, and I will show 2 samples, actually 3. First a lapping bracket, so-called lapping bracket. That's from here to there, this situation, and these brackets are so-called rule-based. The size which is presented here is based on the size of the bracket, of the profiles. So you just need only need to press OK and the right bracket is over there. And as you can see, they have a part number because they're so-called standard brackets. Another one over here, that should be this G bracket. This one is not lapping, this is inserted, 200, yeah, there it is. And in this situation I could also have a bracket, stiffener bracket, but that means 3 parts and they are very close to each other, and therefore we have another type of bracket. Actually it is a plate, but it is created as a bracket. And you see it here. Good. So, finished. And these 4 items I'm selecting now. Yeah, these three and this one I'm now copying, but not in length, but now in height, with a distance h1, so one grid distance, and also the same distance in between the copies, and if I'm well, we need 3 copies. Okay, and you don't need to wait for it, of course, but it will be displayed in the hull viewer after a couple of seconds. Alright, now I like to have a look at this frame view 36. So I try to find it in a panel, but it's not there. You see, there are quite some, but 36 is missing. So yeah, how to create that? There are different ways. I think the most easiest way is to open an existing one and change the 3 into a 6, and then we will have the frame 36 with the actual situation. It needs to be saved to get it in, to get it added to the list, and that has happened. Now, of course, you can also use Ctrl S instead of using the button. Some cutouts need to be added because this is now a watertight bulkhead, but it should be an open bulkhead. So cutouts are needed. Yeah. And we see all the openings. Yeah. But these small openings are not enough to get all the ballast water or fuel. What I don't know what will be inside the tank. There needs to be bigger openings, and those I will now show you. We have a lot of possibilities to make so-called openings or holes in cadmatic. First, you can have a fixed hole, so you can put your cursor somewhere on an arbitrary position, like here, and then you can have a hole at the current control, as we call it. And then you can select your hole type, and I want to have a hole of 300 millimeters. And there it is. But we have also more advanced holes, like what we call arbitrary holes. No, sorry, related holes. And they are related to the surrounding structure. So I want to make a horizontal hole here in between this profile, the hull, but with a distance of 350 millimeters from the hull, this profile, and this longitudinal bulkhead, but there the distance should be 300 millimeters. Okay, that has borders have been defined, and now I have to select the hole type as the hint shows me here. I want to have this hole. The height 600, that's far too much, so I think 400 is better value. The width I actually don't know, because the shape is not easy. From the shape you cannot derive the width here, so I leave the 450 like it is. Instead of that, I'm using here the optimized button. and now we'll have a preview, and now you see it very nice fits into the indicated boundaries. Now this is too nice to ignore, so I like to have a few more, so I'm using this extra button, and in height should be the copies, there will be 2 copies, and the step size is H1, is grid, 1 grid distance. Now it looks like I made a typing mistake maybe, so no problem, you can also afterwards copy it. H1 again. Alright, you see the 12mm is still inside the hole, but after an update it looked for a free position, and now it's okay. Sometimes it's required to have face plates inside the holes, so we have maybe I'll show that. Face plates in hole, so you select the hole or holes, maybe I do these 2, and I take 150 × 10 face plate, and there they are, and it looks quite nice in the hull viewer. You can see here, there they are. I already spoke about some filters, that we also have a material filter here in the hull viewer. Up till now only the standard material has been used, but maybe as an example I could show here to change the material of one plate. That can be done by the logistical data button. I'm selecting the plate and I'm changing the material in another type, confirm it, and update the view, and now you see it is also displayed here. And in the viewer it should have another color when using the M filter. It's not very good to see, but not so much different, but yeah, you can see it's indeed another color. Alright, and yeah, changes. Shipbuilding is full of changes, and one change could be that the contents of the tank is too small, so that this bulkhead has to be moved to get more volume. So let me show that. So I select the bulkhead, I want to shift it 250 millimeters inwards, and you see everything is connected to each other, so everything is changed except this 2D item. This is still on the original position, has to be moved manually, and that can easily be done using the set on the keyboard, and that's it, it's okay. But I like to move the bulkhead back to its original position, so once again the 250 millimeters. Then go. And maybe by now Ctrl Z is also working to have this annotation back on its good position. Okay, that's about I think about the modeling of the inner structure. I also like to show a little bit about the modeling of the shell plates. So therefore we have to move to the shell application. Yeah, so now we are in the shell application, as you can see here, and to be able to create shell plates you first need to have a shell view. That can be side, top or aft view, doesn't matter, but any view should be there. In this situation I prefer the side view to be created, and you just press the create button. Yes, save the view. Yeah, there is one, and we see here the lot of green lines. These are of course the stiffeners or the shell frames I created, and the vertical and the horizontal ones are the butts and the seams. There's also one seam which better could be removed, so that can be easily be done, and it's gone. So now if you need additional seams or butts, you can use the construction and the hull line option, but as said, they are already there, so there's no need for it. I will right away go with the creating of the shell plates. This button, thickness will be 12 millimeters, and I just have to indicate the borders of the shell plate, so that the butts, seam, and that's it. So the 4 borders, and press OK, and it should be here, and you see it here. There it is. Now maybe one more, same idea, enter to repeat my previous command. I want to have a 10 here. 1, 2, 3, 4, and that's it. Okay, I think now it's time to do some to show some production output, because that's the ultimate goal, to have production data to build the block. So I will return to 3D contact. Now it's even faster to open from here the top view of this upper deck. Yeah, so this one we already have seen a couple of times. And yeah, before I go to production, I would like to show about